Every year, over 300 million tennis balls are used across the world in tournaments and casual games. But have you ever stopped to wonder how that rubber core becomes the iconic fuzzy green ball we see bouncing on courts? Let's dive deep inside the intricate, high-precision world of tennis ball manufacturing. It all starts with two vital materials, rubber and felt. The rubber forms the bouncy core of the ball, while the felt gives it the texture and signature green color. Massive rolls of rubber arrive at the factory, where they are mixed with custom chemical ingredients to enhance strength and bounce. This mixture is shaped into flat sheets, which are then pressed into molds that create the perfect hollow half spheres. These halves are carefully ground for uniformity before they're coated with a strong adhesive and fused together to form the complete ball. Once molded, the balls must cool down before being dipped in glue for the next layer, the iconic green felt cover. Precision cutting machines slice sheets of felt into perfect patterns. These felt pieces are then glued onto the rubber cores. Industrial machines wrap the felt firmly, pressing it into place so it won't peel off during play. Next comes a crucial stage, pressurization. The balls are placed in a sealed, pressurized chamber. This step ensures each ball has the perfect bounce and isn't too flat or stiff. Once pressurized, they're sealed in airtight cans, preventing air leakage until they're ready for the court. Meanwhile, over in a different part of the food industry, something entirely different is taking shape. Let's look at walnuts. First, the walnuts are thoroughly washed and then sent down a conveyor belt for sorting. Once dry, they head into high-efficiency cracking machines that split the shells while protecting the delicate nut inside. The extracted walnut pieces are collected, weighed, and sealed, ready to be shipped and savored. Now, let's turn our attention to another crunchy favorite, breadsticks. The process begins by kneading the dough to build gluten, ensuring it will be chewy inside yet crispy outside. The dough is shaped, sliced into long sticks, and baked to perfection. In the mood for pasta, the journey starts with high-quality durum wheat. After cleaning and processing, it's ground into fine semolina flour. Next, high-end blenders mix the dry and wet ingredients to form dough with the perfect consistency. Automated kneading develops the gluten structure, then the dough is rolled into thin sheets. Cutting machines shape these sheets into various pasta types, spaghetti, fettuccine, macaroni, and more. The pasta is then dried in humidity-controlled chambers to prevent mold and ensure long shelf life. Finally, it's packed in airtight wraps with nitrogen flushing for freshness and labeled for shipping. Dough temperature, while glycol-cooled jackets prevent overheating during mixing. Manual labor is obsolete here. Machines orchestrate every step, from kneading to shaping, producing millions of buns daily. In the US alone, McDonald's sells 75 burgers per second, each cradled in a bun engineered for perfection. The McMuffin, often touted as a healthier choice, sparks debate over its sodium and processed ingredients, yet its popularity endures, a testament to the allure of convenience and flavor. Fast food isn't just about taste, it's about systems so refined they border on art. Every bun, every hotcake, is a product of relentless optimization, designed to satisfy billions while maintaining ruthless efficiency. Now shift to the orchards, where dawn breaks over endless rows of peach trees. Their blossoms, kissed by early light, release a sweet perfume that signals the start of a meticulous process. Farmers nourish these trees with fertilizers rich in nitrogen for lush foliage, phosphorus for vibrant blooms, and potassium to fend off pests. Each tree is a living factory, transforming these nutrients into juicy, sun-ripened peaches. Harvest begins at first light, with workers hand-picking only the ripest fruit, soft to the touch, glowing with color. Baskets brim with peaches, gently loaded onto trucks using automated systems to avoid bruising. At the factory, a high-pressure rinse strips away dust and pesticides, ensuring every peach is pristine before processing. Conveyor belts hum as peaches glide towards sorting stations, where high-resolution cameras and sensors assess size and quality, diverting imperfect fruit in milliseconds. Inside the processing plant, peaches destined for canning move to cutting machines. Sharp blades halve each fruit with precision, preserving texture and shape. The halves are bathed in light syrup, formulated to enhance flavor without overpowering the peach's natural sweetness. These machines operate at dizzying speeds, slicing and canning thousands of peaches per hour. The result is a product that's shelf-stable yet bursting with the taste of summer. Canned peaches are a godsend for busy lives. No peeling, no fuss, just pure fruit ready in seconds. Health-conscious consumers value their retained vitamins, while others revel in the convenience. Some plants even brew peach blossoms into tea, a traditional remedy said to soothe stress with its delicate floral notes. Pineapple fields offer a different spectacle. Here, farmers lay black plastic mulch to warm the soil, boosting growth and suppressing weeds. Pineapples, unlike thirstier crops, need only weekly watering, their spiky leaves funneling moisture to the plant's core. As buds mature into flower clusters, farmers test juice samples with refractometers, measuring sugar content to pinpoint the perfect harvest moment. Modern machines have revolutionized this once grueling task. Where farmers once hauled heavy pineapples by hand under scorching sun, automated harvesters now glide through fields, collecting fruit with ease. At the processing plant, pineapples plunge into industrial washers, where high-pressure jets blast away dirt and bacteria from their rugged skins. For juicing, selected pineapples roll toward crushers, their sharp rollers pulverizing fruit into a pulpy cascade. Filters refine the juice, removing solids for a smooth, vibrant finish. Bottling machines pour precise volumes into containers, some unpasteurized to preserve tangy sweetness, others carbonated for a fizzy kick. Pineapples take 18 to 24 months to mature, each plant yielding a single precious fruit, a slow but rewarding cycle. In catfish farms, another marvel unfolds. These fish, natural nest builders, thrive in ponds designed to mimic their wild habitats, dark, sheltered corners for egg-laying. Farmers feed juvenile catfish, a high-protein blend of soybeans, corn, and vitamins, delivered by vehicles that scatter precise amounts across ponds. Giant paddle wheels churn the water, maintaining oxygen levels critical for survival in sweltering summers. Ponds are stocked strategically, fewer fish in cooler months for ample growth space, more in warmer months when appetites surge. Harvest happens at dawn or dusk, when catfish are calmest. Workers drag seine nets, corralling fish into tight clusters before transferring them to chilled holding tanks. A brief resting period precedes processing, where stunning solutions, safe and humane, keep fish relaxed. Automated gill-cutting machines make precise incisions, and icy boxes lock in freshness within minutes. For fillets, V-shaped knives ensure even cooking and a polished presentation. Freezing tunnels at -40 degrees Fahrenheit flash freeze fillets individually, preventing clumping and easing home prep. Catfish nuggets, cut from belly and tail, offer bite-sized bursts of flavor. Remarkably sustainable, catfish require less feed than other species and thrive without environmental harm. Cotton fields tell a story of transformation. In 1793, Eli Whitney's gin revolutionized cotton by separating seeds in minutes, not days. Today, massive harvesters sweep through Texas plains, their rotating spindles plucking fluffy bolls with care. Continuous round baling systems compress cotton into massive transportable cylinders wrapped in protective material. At the gin, towering machines strip seeds with surgical precision, processing tons hourly. Cotton slivers pass through combing machines, their tiny metal teeth aligning fibers into thin, twisted strands. High-speed spindles spin these into yarn, ready for weaving into fabrics. Plain weaves for shirts, knits for stretchy comfort. Finishing treatments, like enzyme softening, give fabrics a silky feel. From field to factory, cotton's journey is a masterclass in automation, turning raw bolls into the clothes we wear. Each of these processes, hotcakes, buns, peaches, pineapples, catfish, cotton, reveals a truth deeper than any viral video. Food and fiber production is a symphony of engineering, biology, and precision, orchestrated to feed and clothe a planet. Every bite, every thread, is the result of systems honed to perfection, delivering consistency at a scale most can't fathom. The next time you savor a hot cake or slip into a cotton shirt, consider the unseen machines, the calculated steps, the relentless pursuit of efficiency behind it. This is the real story, not of shortcuts or scandals, but of human ingenuity feeding the world.